Hello everyone, welcome to our online class. Now in this video we will see linear non-homogeneous recurrence relations of higher order. Okay, so see the higher order. I told you know in the right hand side if the nth term is given, if function in terms of n is given, then how to solve those type of problems we will see in this video. Now see here. So what is the form of the recurrence relation? Cn an plus cn minus 1 an minus 1 plus cn n minus 2 n minus 2 plus so on cn minus k an minus k is equal to f of n. Correct? So earlier we solve is equal to 0 problems. Now here is equal to f of n is there. That means you have to solve left hand side as well as right hand side. Okay. So what is the general solution for this equation? An is equal to an power h plus an power p. That means when we are solving left hand side we get an power h. That means finding roots and all. When we are solving right hand side part we get an power p. Understand? So simple. So when we have a right hand side function in terms of n constant and all, we have to solve non-homogeneous recurrence relations. When we are solving left hand side we get an power h. When we are solving right hand side we get an power p. At the end both we have to add and we need to solve. Let us see one problem, then you will understand how to solve this type of problems. Actually basically an power h is calculated by roots, but an power p, to find an power p we have actually 4 cases. How many cases we have? 4 cases to solve an power p. To solve an power p, how many cases we have? 4 cases we have. Case 1, if f of n is a polynomial and 1 is not a root, f of n is a polynomial and 1 is not a root. 1 is not a root. Okay, ma? And 1 is not a root. In this case, how to take our an power p? So an power p is equal to a naught plus a1n plus a2n square plus so on. Ma. Understand? This is case 1. That means f of n is a polynomial and 1 is not a root 1. Next case 2. F of n is a polynomial. And 1 is a root. In this case, how to solve? An power p is equal to n power m we get additional. In terms n power m we get multiplication. In terms of you have to multiply n power m. So m is what? How many times you repeat 1? Those many times. Understand? This is case 2. Then case 3, if f of n is in the form of alpha into b power n. Case 3, if f of n is equal to alpha into b power n and b is not a root and b is not a root. In this case, how to solve b is not a root? In this case, our an power p becomes a naught b power n. Very, very important cases. If case 4, if f of n is equal to alpha into b power n and b is a root, then an power p becomes n power m into a naught b power n. That's it. N power m into a naught b power n. Understand? So these are the 4 cases to solve right hand side part. How to solve those 4 cases? We will see the problems. So whatever the previous question papers problems are there, from that previous question papers we'll try to solve. Case 1, f of n is a polynomial and 1 is not a root, so we have to use this one. Case 2, f of n is a polynomial and 1 is a root, we have to multiply this by n power m. Then if it is alpha into b power n, so b is not a root, a naught b power n, then b is a root, n power m into a naught b power n. Understand? So quickly we solve one problem, then you will understand how to solve when right hand side f of n term is given. Okay, take the problem. Okay, see the problem. So this is the previous year question paper problem, MFIT, Mathematical Foundation for, okay, no problem. So solve an minus 5an minus 1 plus 6an minus 2 is equal to 4 power n he gave here. He is not given initial conditions, so leave it. Okay. So now how to solve this problem? First what we have to do, we have to solve left hand side part. So characteristic equation k square minus 5k plus 6 is equal to 0. So roots are k minus 3 into k minus 2 is equal to 0. So k1 is equal to 3 and k2 is equal to 2. So an power h, a into k1 power n, b into k2 power n. So this is our an power h. Correct? Now what we have to find? We have to find an power p. Understand ma? So given you write down and mark it as equation number 1. So just I wrote like this ma. So if you want to take the given, so mark it as equation number 1. Understand? Now we have to find an power p. So an power p, here what is f of n? F of n is 4 power n. That means which form it is? Alpha into b power n form. Which form? Alpha into b power n. So what is alpha here? 1. What is b here? 4. So 4 is not a root. Understand? So 4 is not a root. So therefore our an power p, to find an power p, so an power an power p is equal to, what is the formula we have to take? A naught into, what is the formula ma? A naught into b power n, no? A naught into b power n. So here our b is what? B is not a root. Understand? So b is not a root. Correct? So that means, so therefore a naught b is how much ma? 4 power n. B is what? 4 power n. This value we have to substitute in 1. So from 1, so this value we have to substitute here ma. an means what it become? A naught 4 power n minus 5 4 power n minus 1. Correct? So an minus 1 means a naught 4 power n minus 1, 6 a naught 4 power n minus 2 is equal to 4 power n. So this value a naught 4 power n, wherever nth term is there you have to substitute. Here an, so directly 4 power n. Here n minus 1, 4 power n minus 1. Here n minus 2, 4 power n minus 2. That's it ma. Now take out a naught 4 power n, 5 a naught 4 power n by 4, 6 a naught 4 power n by 4 square is equal 4 power n. So which term we can take common? 4 power n common and a naught is common. So what I get here? 1 minus 5 by 4 plus 6 by 16 is equal 4 power n. 4 power n get cancelled ma. So 1 is left here. A naught is equal to a naught, if I take 2 3s are 2 8s are, if I take LCM is 8, 8 minus 10 plus 3 is equal to 1. So a naught is equal to 8 by 1. That means a naught is equal to how much ma? 8. So a naught value how much? To calculate a naught we substituted. So I got a naught is equal to how much? 8. Understand? So therefore if I got a naught value is 8. What we have to do? This implies an power p is equal to a naught is 8, no? 8 into 4 power n. That's it. Very simple it is. Understand? Identifying the type is important here. So right hand side 4 power n is there. F of n is equal to alpha into b power n. It is not a polynomial. It is in the form of alpha into b power n. So general solution an is equal to a into 3 power n plus b into 2 power n plus 8 into 4 power n. That's it. The initial conditions are not given. So still till here we have to stop. Understand? So very simple problem. Only thing is this part a naught b power n. So b is not a root. So we get 4 power n. So this part we have to substitute here to get the value of a naught. So I got the value of a naught. So is what? How much my a naught value? 8 I got. I substituted 8 here. So general solution is what? An power h plus an power p. Both you have to add and you need to substitute. Clear ma? Okay. Next problem. Next problem number 2 ma. See here. So an solve an plus 2 plus 3an plus 1 plus 2an is equal to 3 power n, a naught is equal to 0, a1 is equal to 1, he says. So that means same alpha b power n formula, correct ma? So I am writing, so okay, now write given an plus 2 plus 3an plus 1 plus 2an is equal to 3 power n, mark it as 1. Here initial conditions are given ma. Now what is this becomes characteristic equation k square 3k plus 2 is equal to 0. So what are the roots I get here? If I use the calculator, I get k1 is equal to plus 2 no, minus 2, and k1 k2 is equal to minus 1. Understand? So if you want, you can use the calculator and you can solve it ma, no problem. So k1 is equal to minus 2 and k2 is equal to minus 1 I got. So an power h is equal to what? A into k1 power n minus 2 power n plus b into k2 power n. This is our an power h. Now we have to solve an power p no. So here to find an power p, so what we have to do here? So to find an power p, what is b value here? See, f of n is equal 3 power n, which is in the form of alpha into b power n ma. Alpha is equal to 1, b is equal to 3. So 3 is not a root, correct? If 3 is not a root, then what we have to take? A naught into b power n. So that means a naught into 3 power n, since b is not a root, correct? So in the previous problem also same thing. If b is a root, then how many times it is repeating, that many times you have to write, and n power m you have to write. That means if 3 is coming 2 times, you have to take n square. If 3 is coming 1 time, you have to take n power 1. But here no need, because 3 is not a root, correct? So this value we have to substitute here ma. So therefore from 1, if I substitute a n power p, so this value in place of this, what I get here? A naught 3 power n plus 2, 3 a naught 3 power n plus 1 plus 2 a naught 3 power n is equal to 3 power n, correct? So this can be written as a naught 3 power n into 3 square, 3 into a naught 3 power n into 3 power 1, 2 a naught 3 power n is equal to 3 power n. Take out a naught 3 power n common, I get 9, I get 2 is equal to 3 power n. 3 power n got cancelled ma. So a naught is equal to 1 by 20. So what is a naught value I got? I got a naught is equal to 1 by 20, correct? So therefore my an power p becomes a naught into b power n, that means 1 by 20 into 3 power n. This is my an power p value. Understand? So I got an power h, I got an power p. So both the general solution, therefore general solution is what? An is equal to an power h plus an power p ma. Both we have to add it. That means a into minus 2 power n, b into minus 1 power n plus 3 power n by 20. This is our general solution. But he gave here initial conditions. A naught is equal to 0, a1 is equal to 1 he gave here, correct? So if I substitute initial conditions, so where we'll write, okay, let it be move this side. 1 second. Is it enough? Yeah. Okay, 1 second. Let it be little. So I'm solving over here. Okay, I'm solving over here ma. This is coming no? Yes, this is coming little bit. So initial conditions he gave, given initial conditions, a naught is equal to 0 and a1 is equal to 1. If I substitute n is equal to 0 here, what I get here? So a naught is equal to 0, so 0 is equal to anything about 0 1 a, anything about 0 1, anything about 0 1. I get a plus b is equal to 1 by 20, sorry, a plus b plus 1 by 20. So that means a plus b is equal to how much ma? Minus 1 by 20 I got. A plus b is equal to minus 1 by 20 I got. Suppose if I substitute n is equal to 1, a1 is equal to 1, so a1, then minus 2a minus b plus 3 by 20. So that means 2a plus b, 1 will come this side, minus 1. So 2a plus b, 3 by 20 minus 1 minus 17 by 20 ma. So solve using calculator a plus b. So if I solve the calculator, I got using calculator I got a is equal to minus 4 by 5. Using calculator I am telling you ma. So a is equal to minus 4 by 5 and b how much I got? 3 by 4. So b I got 3 by 4. So therefore both a and b values where we have to substitute here. So therefore general solution an is equal to a how much I got? Minus 4 by 5 minus 2 power n, and b is how much I got? 3 by 4 minus 1 power n plus 3 power n by 20. That's it. Understand? So whenever the right hand side the function is given in terms of f of n, we have to solve like this. Understand ma? 3 power n. So there is one more problem in the previous year question papers which I shared, the video which I shared. Just go through that. 7 power n is there. So similar problem you can solve it ma. Now we will see polynomial is given, how to solve. When the polynomial is given, how to solve that type of problem we will see ma. Now see in this problem ma. So what is asking, solve an is equal to 3an minus 1 plus 2n is and with the initial condition a1 is equal to 3 he says. Okay. So this is a simple problem I took here. So actually it is there in the previous problem, right? Previous year question paper. So given can be taken as, or directly write characteristic equation ma. Now first you write given is what? an this term will come this side, minus 3an minus 1 is equal to n. So this is our f of n. So therefore characteristic equation is what? K minus 3. Only direct, this is only one term is there, first order. So k is equal to 3, only one solution. If k is equal to 3, what you get here? General solution. So an power h is equal to a into 3 power n, c naught. Correct? A into 3 power n. Now what is our f of n here? F of n is equal to 2 power n. It is a polynomial. Correct? And in the roots 3 is there. 1 is not a root. So 1 is not a root. Correct ma? So therefore an power p, no, right hand side part, what we have to do? An power p is equal to 1 is not a root, a naught plus a1n, till a naught and a1n we have to take. Two terms, no, nth term is there, correct? So till here. So that means this term we have to substitute here. So from given, so what I get here? an means this full term as it is a naught plus a1n. 3 into an minus 1, a naught plus a1 into n minus 1 is equal to 2n. Right? Is equal to 2n. Now calculate the values of a naught and a1 ma. This is an power p. Actually I need a naught and a1 from here. So what I get here? A naught. Understand? If 1 is a root, then what we have to take? We have to take n power m. So how many times it is n is coming? 1 is coming, those power m we have to write. But here 1 is not a root, no. So no need to take this part. So see that 4 conditions, okay. So a1 into n, a1 into n, minus 3 a naught, minus 3 a1n, minus into minus plus 3 a1 is equal to 2n ma. Correct? Now simplify this part. If I simplify, a naught minus 3 a naught minus 2 a naught plus 3 a1, okay, a1n minus 3 a1n minus 2 a1n is equal to 2n. Now equate the coefficients of constants and nth terms ma. So I get minus 2 a naught plus 3 a1 is equal to 0 and minus 2 a1 is equal to 2. I equated the coefficients. Equating coefficients equate. So a1 is equal to how much here? Minus 1. If a1 is equal to minus 1, minus 2 a naught minus 3 is equal to 0, minus 2 a naught is equal to 3, a naught is equal to how much ma? Minus 3 by 2. A naught is equal to how much? Minus 3 by 2. So therefore I got the value of a naught and value of a1. So this implies an power p, correct? An power p, a naught is how much I got? Minus 3 by 2, and a1 is how much I got? Minus 1 into n. So therefore general solution an is equal an power h, a into 3 power n plus an power p, no. So that means minus 3 by 2 minus n ma, correct. Now he gave the initial condition a1 is equal to 3. He gave the initial condition. What is that initial condition he gave here? a1 is equal to 3. I am writing this side. So therefore a1 is equal to 3, right? If I take a1 is equal to 3, n is equal to 1, I have to substitute, no? So that means a1 3 is equal to a into 3 plus n is equal to 1, so minus 5 by 2, correct. This will come this side. 3 plus 5 by 2 is equal to 3a. 6 plus 5 11 by 2 is equal to 3a. A is equal to 11 by 6. That's it. So we'll substitute here. So this implies a, how much I got? 11 by 6 into 3 power n plus minus 3 by 2 minus n. That is the last answer after calculating a value. Understand ma? So like this you have to solve when the right hand side polynomial is given. This is actually simple problem. Suppose if it is a little bit big problem, so you will get little bit more, you have to equate both sides, then you have to find a naught, a1 values ma. Understand? So these are the non-homogeneous recurrence relation when right hand side is given, right? Now we solve one or two important problems. Fibonacci series we will see how it look like. See that problem, okay? Yes, next problem, Fibonacci sequence. So he's asking solve Fibonacci sequence through recurrence relations, okay? Very important, and it's a very, already you heard Fibonacci series also. So generally Fibonacci series recurrence relation is denoted by denoted by, so how it is denoted? It is denoted by fn plus 2 is equal to fn plus 1 plus fn, or you can take an also, no problem. So with initial conditions f naught is equal to 0, f naught is equal to 0 and f1 is equal to 1. F naught is equal to 0 and f1 is equal to how much ma? 1. So first, and now how to solve? So this can be solved fn plus 2 minus fn plus 1 minus fn is equal to 0, second order, right? So characteristic equation is how to write k square minus k minus 1 is equal to 0 ma. K square minus k minus 1 is equal to 0. So using one second, using calculator, what I get here, 1 second, 5 may 3 1 equal to minus 1 equal to minus 1. So what I am getting here? So I am getting here k is equal to 1 plus or minus root 5 by 2. 1 plus or minus root 5 by 2 ma. That means, so k1 is equal to 1 plus root 5 by 2 is one value, k2 is equal to 1 minus root 5 by 2 is another value. So therefore general solution fn is equal to a into k1 power n, two different roots, no, power n, plus b into k2 1 minus root 5 by 2 whole power n, correct? So this is marked as equation number 1. He gave initial conditions, no, given f naught is equal to 0 and f1 is equal to 1. So we have to substitute those initial conditions ma. So if I substitute here, so this implies put n is equal to 0. If I substitute n is equal to 0, I get 0 is equal to a plus b, anything about 0 1 and anything about 0 is 1. If I substitute n is equal to 1, I get 1 is equal to a into 1 plus root 5 by 2 plus b into 1 minus root 5 by 2. Understand? So a, from here a is equal to how much? Minus b. So if I substitute minus b here, so 1 is equal to b will come common. So minus 1 by 2 minus root 5 by 2 plus 1 by 2 minus root 5 by 2. Minus 1 by 2 minus 1 by 2 cancel ma. 1 is equal to b into minus root 5. So b is equal to 1 by minus root 5. So a is equal to 1 by root 5. So both a and b will substitute here. Fn is equal to 1 by root 5 is common, 1 plus root 5 by 2 whole power n, and here minus 1 minus root 5 by 2 whole power n. That's it. That is the answer. Understand? Very important and very simple problem it is. Okay, go through it. Fine ma. So these are the few important problems in recurrence relations. we will see using generating function recurrence relation in the next video. That is for CSE student it is there. For AADS and IT students, I think AADS students it is not there, ma. Anyhow, we will see that one or two problems on that. Thank you.